All right, this lesson is all about the law of sines. In the previous lesson, we talked about the law of cosines and how our need for solving oblique triangles, again, triangles that don't have a right angle in them. And law of cosines works really well when you have lots of sides for information, or you have a side and a matching angle. And law of sines is used if you have a lot of angles for information. And it looks like this. So it is the sine of angle A over little a, and the sine of angle B over little b, and the sine of C over little c. And it can be reversed or flipped, so you can also have it where the the sides are on top and the angles are on the bottom. It does not matter. The math will come out the same either way. So whichever way you want to set it up is totally up to you. This one's a little bit easier to solve in terms of keystrokes. It's a little more difficult to make mistakes on law of sines than it is law of cosines, but let's go ahead and just try two of them. So the first one just says, can we find all the missing measures? Again, this is a law of sines question because I've got two angles already, and if you remember, there's 180 degrees in a triangle. So I take 180 minus the 70 minus the 81. I already know that this angle is 29 degrees. So law of sines works really well when I get the angles. You could attempt to set this up for law of cosines, and then you would find out that you have way too many, oops, I just wrote cosines, that you have way too many variables and all in the wrong spots. So that would make you move over and try law of sines instead. So we'll do sine of 29 over 10, and we'll do sine of 70 over b, and sine of 81 over c. And then when you are cross multiplying and dividing, or when you're solving a proportion, you really only need two of these at a time. And you can pick which two that you use. It doesn't matter to me. This one is not solvable because you'll end up with two variables when you cross multiply. So I'm just going to cross off this last one and do this part first. So we're going to do 10 times sine of 70. And then that would equal b times the sine of 29. Oops, degrees, symbols. So mathematically what we're doing is 10 sine 70. I'm going to get that decimal right there. And then I'm going to divide off the sine of 29. That's going to have to come over here and be removed from the right, moved to the left. So now I've got b equals, and as soon as I hit sine divided by sine of 29, looks like it's about 19.38. Remember, this is a side length, lowercase letter, and then you just kind of look up at your picture and go, okay, well 29 was across from 10, that's smallest angle across from smallest side, and we just found b. B is the middle one, so 19.38, that makes sense, definitely bigger than 10. And since 81 is the biggest angle, when we solve for c, we better get a bigger number than 19.38. So in order to solve for c, I'm just going to cover up this middle, and we're going to do this cross multiply and divide. So I'd have 10 sine 81, and then I would have c sine 29. And we're going to do the same thing. I'm going to type in 10 sine 81, and then I'm going to have to divide by that sine 29 to get it over to the other side. So we are finding out that that little c, that side, is 20.37. And again, that makes sense. This was our biggest angle. C should be our biggest side, and it is at 20. Should be pretty close to this one, 70 and 81. They're pretty close to each other as well. So that's how you can do a law of sines. It's a little bit easier mathematically than law of cosines. Do an a word problem here quick. It says a pole tilts towards the sun at an 8-degree angle away from the vertical, and it casts a 22-foot shadow. So here's the ground. My pole, well, let's draw the sun. I am leaning towards the sun 8 degrees. So what it means is the pole should be in the ground at a right angle. That's what it should be doing. And it's not doing that. From the vertical, it's leaning 8 degrees towards the sun. It does cast a 22-foot shadow. Shadows are on the ground, so the 22 is going to go down there. What is the angle of elevation from the tip of the shadow to the top of the pole? And we've talked about angle of elevation before. That'll be down on the ground, and we're looking for how tall is the pole. So this angle right here is 8 degrees, and then tacked on with my 90, that makes this angle down here 98 degrees, because that pole is tilted 8 degrees away from vertical. Oh, sorry. Well, the angle of elevation is 43. I didn't mean to put a theta there. Too much talking and writing at the same time. So I've already got two of the angles, and this is a law of sines question, because when we get two angles, then it's very easy to find the third one. Is do 180 minus the 98 minus the 43. And I found out that my last angle in that triangle then is a 39. So that's up in this tiny little corner right there, sneaking it in. Remember, this 8 degrees is how far away from vertical it is, so that does not influence that 39 at all. So we've got sine of 39, and that goes with 22. Then we've got sine of 98, and that actually goes with nothing right now. I'll put a y there, but we aren't looking for that value. And then we've got sine of 43, and that goes with x. So since that's the one we're after, I'm just going to kind of cross that one out. I'm not even going to use it. I'm going to cross multiply and divide these two. So I'm going to have 22 sine 43 equals x sine 39. So 22 sine 43, and we're going to divide by sine of 39. Found out that that pole is about 23.84 feet. There we go. One left, solve the triangle. So it's got slightly different information. It only has one angle. Makes you kind of think that this might be a law of cosines problem, especially when you have the 10 that's right across from it. So let's try and set it up. So it would be 10 squared equals 7 squared, and then we don't know this one, so I'll just throw an x there. Plus x squared minus 2 times 7 times x with a cosine 112. Looks like it should be easy to solve. Like I could move this 7 over here, and then we'd be a little bit stuck because we would end up with a squared here. And this is a number, that's a number. I'd have to put all that together. What you'd actually have to end up doing in the end is a quadratic formula, which you totally can do, no biggie. Or you can just say, I'm not in the mood, and let's try and set up law of sines instead. So I've got sine of 112, not again. I just want that to be a degree symbol. Sine of 112 goes with 10, and then sine of b goes with 7. And then we've got sine of a going with, I know I throw an x there, but it would just be little a. So right away I can solve this cross multiply and divide. So I'm going to do 7 times sine of 112. I'm going to divide by 10. So it's 7 sine 112 equals 10 sine b. We divided by 10, we ended up with 0.649. Don't forget that now you need to do an inverse. So the sine inverse this time tells me that angle B is about 40.47 degrees. Once I know that one, I can go ahead and do 180 minus to find this one. So 180 minus the 112 that we were given in the problem, and the one you just found tells me that angle A is about 27.53 degrees. Then we need to find little a. I'm just going to cross off this middle fraction. This is the cross multiply I'm going to do. So 10 times the sine of 27.53 equals a times the sine of 112. So in order to solve for a, we're just going to divide that over. So 10 sine that 27.53. I'm going to divide by sine of 112, and found out that my little a is about 4.99. I don't know if you measure, unit of measure, so. Oh, I do, it's inches. Lovely. So this was 112, largest angle should be across from largest side. That is, I had about a 5-inch side that should be across from A, which was my smallest angle, 27. My middle angle was 40, and it had a length of 7. So everything matches up in my triangle, and that is the law of sines. And you can, again, you can have them be either way, just as long as either all the angles or all the sides are on top.